FastMCP2's asynchronous task protocol enables concurrent operation execution through a callback-driven status monitoring system, allowing client applications to maintain responsiveness while long-running computations progress in the background. The implementation leverages Python's native Asyncio event loop to orchestrate non-blocking workflows, with the client class providing a context-managed interface for tool invocation and result retrieval. We'll examine how the code initializes a background computation task, registers a status update handler, performs concurrent work, and ultimately retrieves the final result, all while maintaining clean separation between computation and control flow.
Import Asyncio. From FastMCP import client. Async def main. Async with client server as client. Hash start background task. Task equals await client call tool. Slow computation. Duration 10. Task equals true. Hash subscribe to updates. Def on update status. Print progress, status message. Task on status change on update. Hash do other work while task runs. Print doing other work. Await Asyncio, sleep 2. Hash wait for completion and get result. Result equals await task result. Print for result content. Asyncio run main.
This example demonstrates FastMCP2's asynchronous task pattern, where long-running operations execute in the background while the client remains responsive. The workflow begins by initiating a background task with call tool, passing task equals true to trigger asynchronous execution. This immediately returns a task object, allowing the client to continue processing while the server handles the computation. The pattern leverages event-driven updates through onStatus, change, enabling real-time progress monitoring without blocking. This is particularly valuable for operations with variable completion times, as it provides user feedback while maintaining system responsiveness. The example shows graceful integration of concurrent operations, where the client performs other work, Asyncio, sleep, while awaiting task completion. The design choice to use callbacks for status updates, rather than polling, reduces network overhead and provides immediate feedback. When the client eventually awaits task result, it blocks only until completion, demonstrating the pattern's balance between responsiveness and simplicity. This approach is ideal for I/O-bound applications where maintaining user interaction during processing is critical, though it requires careful error handling for failed tasks in production scenarios. Let's break it down.
Import Asyncio.
Imports Python's built-in Asyncio module for writing asynchronous code using coroutines, tasks, and event loops.
From FastMCP import client.
Imports the client class from the FastMCP module, providing access to FastMCP's client functionality for making remote procedure calls with optional version specification.
Async def main.
Defines an asynchronous function named main that serves as the entry point for the program's execution. The async keyword indicates this function will contain asynchronous operations, allowing it to use await expressions for non-blocking I/O operations.
Async with client server as client.
Establishes an asynchronous context manager for a FastMCP client connection to the specified server. The async with statement ensures proper resource cleanup after the block executes, while client server creates the client instance bound to the given server endpoint.
Task equals await client call tool.
Asynchronously calls the call tool method on the FastMCP client instance, awaiting its completion and assigning the result to the variable task. The method invocation suggests interaction with a tool or service through the FastMCP client, with the await keyword indicating this is part of an asynchronous operation that will suspend execution until the call completes.
Duration 10.
Sets a duration parameter to 10 in a dictionary or JSON-like structure. This appears to be configuring a time-related value, likely specifying how long an operation should run or wait, measured in some unit seconds, milliseconds, etc., based on the context where this dictionary is used.
Task equals true.
Sets the task parameter to true in what appears to be a function call or configuration object, likely enabling task-specific behavior in the FastMCP context. The exact effect depends on the surrounding code, but this line explicitly activates the task-related functionality.
Def on update status. Print progress, status message.
Defines a callback function named onUpdate that accepts a status parameter. When invoked, it prints a progress message by formatting the string progress, followed by the status message attribute from the past, status object. This function serves as an event handler that outputs status updates during some asynchronous operation.
Task on status change on update.
Registers the onUpdate function as a callback that executes whenever the task's status changes. The onStatusChange method takes a function reference and will invoke it automatically during status transitions, passing relevant status information to the handler.
Hash do other work while task runs. Print doing other work.
Prints the string doing other work to the console, indicating that the program is performing additional tasks while another operation runs concurrently.
Await Asyncio, sleep 2.
Pauses execution of the current coroutine for 2 seconds without blocking the event loop, allowing other tasks to run during this time. The await keyword indicates this is used within an asynchronous context, and execution will resume after the specified delay.
Hash wait for completion and get result. Result equals await task result.
Awaits completion of the asynchronous task and retrieves its result value. The await keyword suspends execution until the task finishes, then task result returns the computed output. This is the standard pattern for obtaining the final value from an async operation in Python.
Print for result content.
Prints a formatted string that displays the text, result, followed by the content attribute of the result object. This uses an f-string to embed the result content value directly into the output string.
Asyncio, run main.
Runs the main coroutine function using Asyncio, run, which executes the asynchronous code and manages the event loop until the coroutine completes. This is the entry point for executing the async program. FastMCP2's asynchronous task protocol shines through its callback-driven design, where call tool with task equals true immediately returns a task object, enabling concurrent execution without blocking the client. The onStatusChange callback provides real-time progress updates, eliminating the need for polling while maintaining responsiveness. This pattern is particularly effective for I/O-bound operations, as demonstrated by the client performing other work, Asyncio, sleep, while awaiting task completion. The final, await task result, cleanly retrieves the result only when needed, balancing simplicity with non-blocking execution. The design choice of callbacks over polling reduces network overhead, though production use would require additional error handling for robustness.
The task spawns a listener before birth, yet its final result arrives before the first heartbeat.